Kind of like a countdown. Hello, everyone. Good morning, good afternoon, good evening, wherever you're joining us from. Hello. I will jump right into the comment sections. So we have a lot of comment sections here. Uh, but just before I do that, my name is Vincent, and today we'll be learning about the cloud. Uh, so, I'm Vincent, and Major League Hacking content streamer here, and I'll be your host today. Today we'll be looking at what a cloud is, and we'll take a look at the difference between the cloud and your personal computers, and we do some demos to see how we can actually spin up our first cloud machine. And we'll have questions. So this is going to be very interactive. Uh, Let me just dive right into the comment section. So I see like you have some questions right there already. Like tell me what I have to do in this hackathon. I'm beginner. You just need to be here. You just need to follow along. If you have questions you want to ask, you just need to ask. That is all you have to do. And you'll be needing just an AWS account or an Azure account just for the demo purpose, just to see how we can spin up a virtual machine at the end of the stream. So if you don't have if you don't have an AWS account, you can go ahead and sign up for one. I'll be dropping the link on the comment section where you can sign up as well. Hi everyone. Hello. Hi Ash. How are you doing today? Hello. Hi Nacho. Good morning. Hello, good afternoon. So good morning, good afternoon, good evening, wherever you're joining us from. Let's have a little chat on the comment section. So tell me, just when you hear about cloud computing, what comes to your mind? Hello, good morning. I see the question. What are we going to do today? We're going to learn about the cloud. We're going to learn about the cloud. We're going to learn what the cloud is. Is it magic? You must have heard the word the cloud before. So what is it all about? So we're going to learn about what the cloud is today. So if you have heard about the word cloud before, let me know on the comment section. What have been, oh no, what comes to your mind when you heard about it, the word cloud? Oh, I see. So VSM photographer say AWS come to my mind. Awesome. Okay. Do I have any other person? So when you hear the word cloud, what comes to your mind? Okay, cloud is like your storage on the web. Yes, that's correct. Okay, I have another comment section. He said like AWS, Google Cloud Platform. Yes, that is absolutely correct. So this is what comes to your mind. The very first time you heard about the cloud as a service, cloud as a service. Yeah, cloud as a service is literally a service. Think about it like a rental. You can rent something, so it's a service, or you're rendering a service. Okay. Someone says it comes as a so when they heard about the cloud, think about cloud as a software as a service. Yeah, software as a service. Yeah, it's all part of inside the cloud as well. So today we'll actually take a look at what the cloud is, what is not, and we'll take a look at how we can actually spin up our own cloud at the end of the day. So I'll be keeping my eye on the comment section while I'm on the screen, so that if you have any questions along the way, feel free to ask, and I'll be here to answer. Okay. So let's cue the. Okay, I have another comment here. It says we heard about the cloud giving someone storage for other people's websites or applications. That's what comes to their mind. Awesome. So all the comments are valid. All the comments are all related to the cloud. They are literally all part of the cloud, all joined together, right? So let's actually take a look at it. What the cloud really is and what it's not. So the cloud is literally other people's computer, right? That is exactly what the cloud is. So let's cue the math of it's in the sky. So when you hear the cloud for the first time I heard the word cloud computing, I was like, is it magic? Is it on this? Is it somewhere on the sky? And how do we have access to it? And how do we use it? So it was like a buzzword for me for the first time until I figured out, okay, what it really is. Funny, it is literally what we have been using on a daily basis. It is your computer, right? It is your machine. The difference is sometimes you turn off your machine, sometimes you restart your machine, and your machine, that's your laptop, your desktop, it may not be enough for other people to use or borrow. Is your personal laptop, and it may not have all the whole power that you need for other people to run on it as well. Okay, so I have a comment right here. It says, "Is Drive a cloud as well?" Yes, it's all part of the cloud, like Google Drive, Microsoft Drive. Is all part of the cloud. Okay. So when we hear the word the cloud simply means is a computer. It's other people's computer, right? It's someone's computer sitting somewhere in the world, but the difference is it's accessible through the internet, and it's always on, and it is scalable, right? You can always expand, you can always extract as well. So it's very flexible. So, but it is the same computer we have. When you look at your laptop have storage, your laptop have memories, it have CPUs running on them. It is the same thing with what we call the cloud. The only difference is, think about the cloud. Uh, think about the cloud like a rental service, right? I have a comment right here that says servers and storages over the internet. Exactly. Think about the cloud as a rental service. When you rent an Uber, you want to go from point A to point B, you pay for the service. Think about it like the cloud. You want to rent someone's computer for a specific amount of time, and you are paying as you are using the services. So that is the way you should think about the cloud. It is someone's computer. It is living somewhere, in the region. You borrow it, and you pay, for what you borrow. So you borrow, you pay base, pay use. So pay per service. That's the term they use in the cloud, space. You pay per service, pay as you go sometimes. So pay per service or pay as you go. So you pay on as you use. Just like when you rent a service or when you book an Uber, you pay based on the destination, based on how many miles that has been covered. So you keep paying. So even if you wanted to reroute your destination, you pay extra. So it's the same concept when it comes to the cloud. It is not magic. It is not floating somewhere in the sky. It is not AI. It is a physical hardware sitting somewhere in the part of the world. And all you need to do is borrow part of it to use over the internet. Just like the last comment right here, I say it's servers and storages over the internet. Yes, it's just your normal computer, but the difference is now it is over the internet, and people can borrow. You can borrow some part of it to make use of. So your laptop versus the server, or your laptop versus the cloud. The differences, again, is the same concept. It's the same thing. It's just a machine, just the same way you have your desktop machine. The cloud is also a desktop or a system, a device somewhere right there that have CPUs, RAMs, that storage that people can borrow. The difference between it and your laptop is your laptop sleeps. It's personal to you, so other people cannot borrow it. You cannot share the resources of the laptop with some other people, because it's a personal laptop. It's a personal belonging. And your laptop sleeps. You turn it off. It goes off the internet sometimes because you want it to cool. You want to turn it off. You are done from work. You want to shut it down. You want to travel. You want to carry it in your bag, and so forth. So the difference between your laptop and the cloud is the cloud is always on, right? The cloud is always on, and also is public, and it is the reason we are communicating right now. The cloud is the reason you can see me. You can see my screen. We can communicate. You can hear me. It's all happening in the cloud because the cloud is always on and it's public and it never sleeps, unlike our personal laptop, right? So think about, we turn off the laptop right now. I mean, nobody will be able to communicate, but because it's always on and it's always public, I mean, is accessible anytime. So I have a comment right here that says, is it necessary to have knowledge of hardware to learn about cloud? Is it necessary to have knowledge of hardware to learn about the cloud? To answer that question, yes. To also answer that question again, not necessarily, right? Think about the cloud as all the whole other components of your laptop, understanding how it works. Think about storage, think about networking. So the physical hardware, I studied computer engineering in school. I studied computer engineering in school back then in college. And knowledge of hardware, we talk about the embedded system itself, the physical hardwares. No, we don't necessarily need to have the knowledge of the physical hardware, but if you're learning about the physical hardware, you also learn about how it works, in between, right? So it's like, if you're learning about the hardware, computer hardware, you're definitely going to learn about networking. You're going to learn how the computers talk to each other, not just the physical parts of it, and the embedded system perspective, but you also learn how they connect and communicate with each other. So you will need some of the skills there, not physically the skill. So the cloud itself, again, these are like servers living somewhere in the world. They also have network engineers who work in these data centers, right? They also have like physical hardware engineers that work in these data centers. So you don't necessarily need to have knowledge of the physical hardware to learn about the cloud, right? So the physical hardware, we have the network engineers, we have the computer engineers who take care of the hardware physically, just like a normal computer. You take care of it as well. You make sure that everything is working perfectly fine. The same applies to data centers in the world where these cloud servers or the servers live. So there are people who take physical care of it. There are people whose job is to make sure that it's being protected. There's the cooling system is working, the hardwares and so forth. The networks are being connected properly. Yeah. So to answer your question, no, you don't necessarily need the knowledge of hardware to learn about the cloud. You just need to understand how the physical computer works, how the networking works, before to learn about the cloud. So I have another question that says, can we get slides of this session? Yes, you can get the slides of this section. I will make it available on the Discord channel. So you can get it, you can get access to it. I have a question that says, why do companies prefer hybrid cloud? Okay, a simple answer to that is security. Yeah, that's why some companies prefer hybrid cloud. They prefer to have some of their things, on the public, and some of the things internally, right? Their own servers, their own hardwares and data centers, and sometimes they can delegate some of the resources also to public servers. So the answer to that question is security. And again, going hybrid is expensive, right? So not everybody can afford it. So most companies that prefer hybrid cloud are mainly big companies that can afford it. So especially let's can look at government agencies, where they have a lot of data that should be private. Banking sectors as well. They have like documents, sensitive informations that they don't want to risk sharing it on the public cloud. Because at the end of the day, you're renting someone's storage. Even though there's always going to be policies guiding the cloud platforms where you're renting from, but they just don't want to risk it. So they want to the more sensitive data, they have it on their own local machine. Like they build their own data center, they have their own data center, their own storage and servers that is only accessible within the organization. It is not accessible, to the public, and then they can actually delegate some of the other informations. Maybe they want to rent it out. They want to rent out servers and host some of the information that could be public. So that is why companies prefer hybrid cloud. It's all about security. There are things they just want it to be private. It remains private. Okay, so I have another question on the comment section, but before I attend to that question, so why apps move to the cloud? Apps move to the cloud for mainly three specific reasons. One is availability, because having your own data center, having your own servers are expensive. So it's starting up, and if you don't have the resources, they move their apps to the cloud, rent servers basically. So when I'm talking about moving to the cloud, I'm specifically saying renting computers to host your applications. That's basically what I mean, to host information. So they are doing that for availability. The power, the resources it takes to have a computer running 24/7, it's expensive to maintain as an individual or as a firm. So availability, so that the system can always be available whenever it's needed. Then again, it's scalability. If they want to scale up or scale down, if they want to put more resources, if they want to remove some resources, it's very easy to do, right? You can literally do that just with a click. And then lastly is reliability. So we have the big companies like AWS, like Microsoft Azure, and these companies have proven over and over again that they have spent billions of dollars in the cloud space. So companies, individuals, startups, they rely on these companies, on these cloud providers, to make sure that their servers are always on and the applications are always reachable. So I'll take the question. So someone asked, what is a community cloud? So within the cloud space as well, um, eh, literally that's what we call public and private cloud sharing. I'll just give you example of what that is. So when it comes to public, think about public as you have one big giant machine, like one big giant desktop, and five people can share the resources of that desktop. So we can, back in the days, networking 101 in school, networking fundamentals, we can literally, you can, partition your system in such a way that different users have different access to it, but they can't actually access one each other's information. That is what we like refer to as a public cloud or a community cloud. Think about your laptop, and you have different users account in that same laptop, and each user have access to their own resources. They can't access other people resources, but they're all in that same one hardware or device. That is a public cloud. But the public there does not mean it is public, like I can access each other's information. No, it means, okay, I have this ton of device, and I'm sharing it within different people, like 5, 10 people are sharing that same hardware, but it's partitioned. So I just come in and partition a piece of the hardware for this user, partition a piece of this hardware for this other user. So that's a public or community cloud. Then private is literally, you're buying the whole machine for yourself. So companies do that. So they don't want a piece of the hardware. They want to acquire, the whole hardware to themselves. So they don't want to share. So that's like a private cloud. So it's all in the cloud. It's just like a physical machine, but you're sharing. And at this point, you're not sharing resources. You're not partitioning. You own the whole machine itself, in quotes. Okay. I have another question that says, in this session, are we learning only cloud basics like SaaS, PaaS, infrastructure as a code, infrastructure as a service, or also going in depth? We are not really going in depth. We're just going to touch the surface, just learn about what a cloud is, what it's not, and then we can actually see how we can spin up a virtual machine, like rented. We can see how we can rent a service in the cloud, also how we can rent storages in the cloud as well. So it's not going to be in depth. We're not going to like go in depth. We're just going to touch the surfaces of the cloud and basically how we can actually rent services using platforms like AWS and Microsoft Azure. Okay. Okay. So the same applies for storage. The same applies for storage where files and data lives, images, video, databases, and so forth. You can also rent them. So it's like all part of the cloud. Think about it like your Google Drive. Think about it like your iCloud or your Microsoft OneDrive, where you can rent a specific amount of storage space to store your informations, and you pay as you use it. So this type of cloud service is basically what we refer to as SaaS, software as a service. So you are paying for the software as you use it, like you're monthly, you're paying annually, and so forth. Okay. So I think I mentioned this already, like someone asked a question where he asked, do I necessarily need a hardware knowledge to learn about the cloud? And the answer was no, but you need to understand how it works. And the way the physical hardware works is all about networking. It's all about this computer talking to the other computer. It's just like when you go to the banking hall, all the computers somehow talk to each other through networking. They normally do the Ethernet, local networking to keep the informations all within itself. So you just need to understand how the computers talk to each other. And in simple terms, it's literally, sorry, give me 1 second. In simple terms, it's literally about the IP addresses connecting to the other IP addresses. It's just like from your computer, you're able to visit a website. You are literally networking. It's literally you talking to the server and the server responding and giving you back information. So if we look at why, this is still on why people, why organizations, why companies, and why you too should be interested in the cloud. So think about it like 10 users versus 10,000 users, right? So the cloud actually allows you to scale. It allows you to grow easily when the traffic grows, unlike when you're not using the cloud. I'll just give you an example. Let's say you are starting up, a company, like a small company or a small startup who are using their own infrastructure, like their own data center. It's again, they cannot spend a lot of money anytime they want to upscale their infrastructure. So if they want to add more RAMs, if they want to add, more storage, more GPUs, more CPUs, they need to physically do that in order to scale. So this is basically where the cloud comes in. With the cloud, it just allows you to actually become automate your scaling and your shrinking as well. So you can upscale, you can downscale when it comes to the cloud. You can automate that process. You can automate If I have more traffic on my device, if I have more traffic on my virtual machine, I wanted to add more RAM. I wanted to add more storage. If the storage is nearing 80% and so forth. Like scaling is very easy. So scaling is can be automated in such a way that your application never goes down or never suffers, the traffic. I think last month I gave a talk and I made a comment. I say your viral moment shouldn't be your downfall. And just to explain what that comment means, it means as you're preparing to build that viral product, as you're building a software, you should not think just about now. You should also think ahead. So if you are building for, let's say, 1,000 users, don't build your infrastructure around just that 1,000 users. So think about what happens if my product goes viral and I have 10,000 users signing up that same day I'm launching. So you should make room for expansion, literally. So that is the whole concept. Make room for expansion. And cloud actually helps you automate, that room for expansion where you can literally scale up or scale down based on traffic, based on use on your, on your device, on your machine, on your software, and so forth. Okay, so I think I've already covered this in a bit, like life before the cloud, before we started hearing about the cloud. People buy servers, they get the traffic, and high upfront costs. They pay for what they are not even going to use. So before the cloud, you literally need your own physical machine to host your own servers, to host your own applications. You also need to guess how many people could visit. So you're always looking forward to how many people will visit my software, how many people will visit my platform. So you assume is always based on assumption before now. So there's always assumption, you build based on assumption. You configure or you add storage or RAM or GPUs based on assumption that could that could help that could occupy the system. So let's say you have built the software, you hosted it on your local machine, you in your own local servers, you make the necessary requirements, the hardware, everything is on, but you have like 1 terabyte of storage, or let's use 1 gigabyte for a start. So what happens when more people sign up for the platform or more people are using the platform, and then let's say you make room for 1 gigabyte, but now the people signing up requires like 2 gigabyte of storage. So there's always a gates before now. So, but with the cloud, it's actually more easy, right? You can literally, something we call auto scaling. You can literally automate the process so that when there's a high performance in a specific aspect of your infrastructure, it can scale up. And also, when there is low performance, it can also scale down. So amazing. So this is before and this is life after. So you pay for what you use. You can scale anytime, no hardware stress. So you don't need to maintain the hardware. Uh, you are just paying for the service. So this comes in different perspective. Either is a SaaS, which is a software as a service, or it's a pass. I just put this comment section right here, so you can look at the acronym, the SaaS, pass, and IaaS. So the SaaS here is like software as a service. Think about software as a service like Google, Microsoft 365, Google Workspace. These are all platform as a service. These are all SaaS. You have a lot of SaaS out there. So you are just paying to use the services. You pay to use the service. You don't worry about what goes behind the scene, the storage or the hardware is not your problem. Then PaaS, which is like platform as a service. Uh, think about it like when you spin up a local machine. No, not really. Think about it like when you host your application, on AWS and you are using let's say App Runner, for example, or you are using Elastic Beanstalk. These are like services that helps you launch your application. You just provision what you need. Like I need such amount of hardware, I need such amount of storage. It provision and host your application on it. You don't worry about the infrastructure per se, but you can actually determine how many storage devices and type of storage you need, type of CPU, type of operating system. So you can configure that, but you are literally not going to worry about the hardware itself. So you just bring your application and put it and host it. Then we have the infrastructure as a service. So this is basically where you do most of the configuration, but again, you are not worrying literally about the physical hardware. The physical hardware is being taken care of. So, but in this case, you do most of the configuration, like installing the OS you need, configuring the specific hardware you need by yourself, and installing the rest of the resources you need inside, the uh, infrastructure. But you're not worrying about the physical one. Okay. So with cloud, you just pay for what you use. I'll give example of where you're paying for what you use. So all these cloud services they have where you pay based on how many minutes your machine stays online. So let's take for example, you spin up a virtual machine, you're paying for the time. So if you pause it, if you stop the virtual machine, you that the time it is paused, you're not going to be paying for it. If it is on, the timing keeps reading. The another example is when you make a call, let's say you are using an API service in the cloud. So each time you make a request to the cloud to do something, you get charged just for that request. So you are not being charged because you have set up a specific resources. Like you have set up, let me use AWS Bedrock, for example, which is like their AI services that has to communicate with all the whole models. Most of the models you make use of are all there. So they're not going to charge you because you set up a Bedrock account. They're only going to charge you when you make a request to it. So that is like pay as you go. So you pay for what you use. You pay for the time. You're renting the service. All right, so I think we already covered this. Almost every applications you are using right now runs on the cloud. Netflix, uh, Amazon Prime, Uber, YouTube, they're all running on the cloud. Most of your software as a services, startups, the SaaS platforms, the APIs, AIs, they're all on the cloud. So this is how important the cloud is. And also, just to bring it down, you may have that question: do I necessarily need the cloud knowledge? Do I need to learn about the cloud? Even if I'm interested in, let's say, front end, back end, or other aspects of tech, do I need to have the cloud skills? Yes, you do, because everything you build also comes around the cloud. They have to be hosted on the cloud. They have to be hosted somewhere, and this is basically where the cloud comes in, right? So everything you build is going to live somewhere. So you need to understand how what you build, how people access it. Most of the job description out there right now expects you to have a cloud knowledge and maybe know how to spin up and deploy an application on the cloud, know how the cloud works, know how to spin up a service on the cloud, know how to connect one cloud service to the other. So it's becoming more of a requirement to have a cloud knowledge for every tech role, be it front end, back end, AI engineer, and so forth. Because at the end of the day, those systems you're building, those platforms you're building, are not going to run themselves. They are going to be run on the cloud. So you're expected to have a knowledge of where what you're building runs. Okay, so just before I dive into beginner cloud roadmap, which I'll be sharing a note, I'll be sharing the roadmap on the comment section soon. Let's dive into getting our hands dirty and doing some of the things we just mentioned right here on the session. Let's go ahead and see how we can spin up a machine on AWS, and also how we can spin up. We'll also see how we can spin up storages on AWS, and we see how we can also do that on Azure. So I just want us to have a feel of the two platforms, AWS and Azure. Uh, they're not the only big cloud providers. We also have Google Cloud Platforms. We also have DigitalOcean. We have which other? Yeah, we have DigitalOcean. I think we have Alibaba Cloud. Yeah, we also have IBM Cloud, and yeah, a whole lot of other cloud providers are there. But the big three guys in the industry are AWS, Azure, and Google Cloud Platform. So these are like the three top cloud providers in the world. So, but now we'll take a look at both of them. So AWS and Azure, and on your free time, you can also explore Google Cloud Platform. The concept is the same, right? It's is computers are the same all over the world. Like your laptop, even if I'm using, let's say, a MacBook, and you are using a HP, at the end of the day, it's the physical hardwares are all the same concept. There's a screen, there's a storage, there's a RAM, there's a CPU. You know, it's all the same concept. So the same applies with the cloud providers. Cars are all the same cars. The logic are all the same. They're always going to have a machine. They're only going to have a RAM. They're always going to have networking. So it's the same concept, but they just name it different convention. So it's all about naming convention. Example, AWS we call virtual machine EC2, right? And Azure we call it virtual machine. Azure we call it Azure virtual machine. Not quite sure what Google Cloud Platform calls it, but it's all the same concept, it's all the same logic, just different naming convention. So you can literally learn about the cloud from using one provider. The other provider, you are literally going to catch up if you want to do the same similar thing from here to here. So it's the same concept, just different naming convention. Okay, I'm gonna share my screen, and we can go ahead and spin up. See how we can actually spin up a virtual machine, log into that virtual machine, and so forth. Okay. For this use case, you need an AWS account. So if you don't have one, I'll be sharing the link on the comment section right here. I think I can go to aws.amazon.com/free. Okay, so you can go to aws.amazon.com/free. I have dropped the link on the comment section, and you can sign up for a free account that you can actually use for learning purposes. While I'm on that, I will also share the Azure on. Yeah, I think that should be azure.microsoft/free. Also, I think they have like they have a free student offer. I will share that as well. Give me 1 second. So for Azure will give you $200 credits you can use on the Azure service within 30 days. For AWS, I think they'll give you up to 100. Okay, new customers, if you're signing up for the first time, you get 200 also dollar in credit that you can use to explore the services for up to 6 months. Yeah, for up to 6 months on AWS, and for Azure, you can actually use that for up to 30 days. Okay, I'm trying to get this exact link. Yeah, I'll just copy that. So I also pasted the link for the Azure free account. So if you visit the link, you should see an option start with $200 Azure credit. So you have like 30 days to use it in addition to the free services. And the other one is for Amazon uh, AWS account. So you can go ahead and sign up for both of them. So I see a comment. Someone says SaaS. What is this? If I get a question correctly, he's asking what is SaaS, right? Yeah. So SaaS is software as a service. Software as a service. I'll just give examples of software as a service. Microsoft 365 is a software as a service. Google Workspace is a software as a service. These are all software as a service. If you use platforms like uh, Twitter, is also a software as a service, right? Uh, YouTube, fill out. Uh, so these are all software as a service. So basically, software as a service are softwares you use without worrying about the infrastructure behind it. So you just have access to the interface and the services. That's software as a service. So you're just paying for what. Okay, you said I'm 17, have not used have not used a software as a service before. Uh, do you have a Gmail? If you have a Gmail, so Gmail is, I believe you have a Gmail, like your email. You can where you access your email. That is also a software as a service. So literally, software as a service is, yeah. So it's an example of a software as a service. It's just an acronym, software as a service. So it simply means you are paying for the service without worrying about the infrastructure behind it. So you just pay for so Gmail has a free trial. I think 15 gigabyte. I think so. If you exceed the 15 gigabytes, I think you have to like upgrade or stuff. Yeah, you have to upgrade. So it's a software as a service. So you pay for it to use it. Yeah. So you don't worry about the infrastructure part of it. That what makes it software as a service. So you don't worry about the where it's hosted. You don't worry about how they host it. You just pay for the service. Okay, so I'm gonna share my screen right now, and we're gonna see how we can spin up a virtual machine on AWS. Okay, so still here, I have another question. Is it used by companies to give out services by paying? Yes. Is it used by companies to give us services by paying? So if I get the question correctly, you are asking if SaaS, which is software as a services, are being used by companies. Yes, to answer the question, there's a question mark. So yes, they are being used by companies to give us services by paying. Now, if companies who build this software, you pay them. So if you pay them, you're paying for the service. So it's like when you pay for Netflix subscription, so you are paying them to watch the movie. Yeah, so the host, the build, the host, the host, the build, the host. So you just pay to use the service. So it's like pay as you go. Some of them have monthly subscription, some annual subscription. So you're paying just to use the service. So that's an example of software as a service. Thank you. If you have other questions, just keep it coming on the comment section. So as you ask another question, is like Vercel or Netlify services? Yeah, you can literally, yeah, you can categorize them as software as a service for hosting your application. So you use these two platforms to host your softwares. Uh, yeah, so they are software as a service. You pay them to host your applications for you without worrying about the infrastructure part of it. Yeah, so they are also part of SaaS, which is software as a service. So if you have signed up for a free account on AWS or Azure, I just wanted to let me know in the comment section. I want to know if you have signed up. I want to know, who is following along on the comment section. So if you have, you should be able to. I mean, you can literally go to console.aws.amazon.com. So you can visit console.aws.amazon.com. That should take you to the sign in page. So that should take you to the sign in page. I'm just going to press that link on the comment section. You can go to console.aws.amazon.com, sign in. I'm just going to click on sign in using my root user. And this will ask me for my email and password. Okay, so I have multi-factor authenticator enabled. I'm just gonna get that code right real quick. And I'll go ahead and sign in. All right, so this is what the AWS console interface looks like. If you're signing in for the first time, you may not see exactly what I have on my screen. So if you have visited often, it will give you like recently visited services and so forth. And I mean, you can just see applications you have running. If you have any, you can see the billing, the cost, and so forth on the screen. And you can search for any services you want. We have options like when you click on the top, what's it called? Menu here to access the services. So you can literally have access to all the whole AWS services right here. So if you click on all services, this gives you all the services from alphabetically. You can access any one of them. You can also search for them right here on the search bar, if you want to access them easily from the search bar. So for our use case, we're going to look at how we can rent a full virtual machine, a full computer from AWS. So we are trying to rent from AWS. Again, this is the cloud, right? So let's say you're trying to rent a computer and you want to host your software in it, and you and your friends can access that software. So AWS calls it EC2, which is a virtual server in the cloud. So you're basically renting a computer on the cloud. So on the search bar, you can just search for EC2, but if you go to the services directly, you should be able to see it under compute. If you click on compute, you should be able to see EC2 right here under compute, because it's a computer, right? So you can click on EC2 from here, or you can also search for it on the search bar, and you can access it. Okay, so while on that, I have a question on the comment section, and that says, if someone have viral and structured ideas about a language, by language, I assume you're referring to by code, not copy and paste, to make the process fast, to innovate much time, not much in building. So will it be fair in this present time? What is your take on this? Okay, I think the question is literally asking, if I understand correctly, but if not, correct me. I think you're asking, what is my take on vibe coding? So you already learn a language. Let's say you learn Python or you learn JavaScript, and you have an idea you want to build. What is my take on using vibe code to make the process faster and innovate? My idea is go for it. Again, most companies are not going to hire you these days if you don't even have experience of vibe coding, right? Because every company they have access to the vibe code tools, Cloud, Kiro, and the rest of them. Engineers are encouraged to use it, so you should use it. Again, it's always advise beginners always learn the fundamentals first. Don't just start by coding without understanding how programming works. So understand what the language, understand how it works. Like, you can build it yourself, but allow the AI to make your work faster. So if it don't take you 1 week to build on your own, the AI can actually help you build it in 2 days or lesser time, right? So again, you're advised to use it. Companies are using it. Companies are using it. Even big companies are using it. There's a tweet somewhere on Twitter from an engineer on that was at Google. They're using cloud, right? So companies are using it. You're advised to use it, but again, you need to understand what is happening. You need to, again, AI is not going to replace humans. You just need to understand how it works. So even if you're vibe coding, you need to understand security loops. You need to make sure you know exactly what is going on, so you can actually correct and prompt the AI properly. I think vibe coding these days is more of prompt engineering, understanding how to prompt, not just prompting, but prompting the right way. Okay, I think you have a pull up where you say the okay, it's have to use, but not just copy and paste. How to build fundamentals. Yeah, so just understand the fundamentals, understand the basics of programming, computer science, networking, system design, understand how the whole software work. So learn again, if you're a beginner, you're learning how to program, learn programming, like leave the fancy guys away, leave the vibe coding tools, leave them, learn the fundamentals, like vibe codes are not there. Learn the fundamentals, learn computer science, learn the programming language itself, understand how to use it without vibe coding. This helps you stay competitive. You understand the logic, you understand the system without the AI. AI should just be a helper. Like, I know how to do this, I know exactly how to do this, I can do it on my own, but it's going to take me maybe 1 month to do, but I want to be able to do it faster, then I bring AI to help me do it faster. Not, I don't know how to do this, and then I'm plugging in AI, and there's going to be disaster at the end of the day. If you don't understand the program, if you don't understand what is happening, it's just AI writing the code. So AI could literally introduce security vulnerabilities and so forth, and you don't know because you don't understand computer science and how it works. So my advice is learn computer science, learn programming, understand it. You should be able to build something without AI. Then use AI because you want to make it faster. Okay, so let's see how we can spin up let's see how we can rent a machine from AWS. So the goal here is to rent a virtual machine. And let me see on the comment section, should we rent a Windows operating system machine or should we rent a Linux? So we can rate Windows, we can rate Linux. So whichever one I have more on the comment section, that's the one I'll go for. Now, let me see your comment section. If you're using Windows, if you're using Linux, meanwhile, if you're using Mac, you're literally running on running on Linux as well behind the scene, right? Okay, I see one Linux, I see one window. So I need majority carries the vote. Yeah, it's a vote. So the more operating system we get, the more we go for. Yeah, I see another Linux. So for now, Linux is winning for now. So we have Linux, Windows, and Linux again. Okay, so why Linux is leading on the AWS console, you can click on, launch instance. So you can click on launch instance, and you can give your instance a name. I don't know. Wait, let's call this Gladman. So this is where we now choose the operating system. So we call it operating system image. If you can see, we have options. We have the Amazon Linux, we have Mac OS, we have Ubuntu, which is also a Linux distro. We have Windows, we have Red Hat, Dublin. These are all running on Linux. You can browse for more, so you can actually click on browse more, and you have access to more images, operating systems, literally. Let me give you a hint on you have different versions of it. Example, you have like Amazon Linux kernel. So is a Linux kernel that have some predefined tools inside it. So it could be lighter, it could be heavier. It all depends on what you are looking for. it all depends on what you are looking for. So there's a comment here. Not really sure I got that. But yeah, I see. Yeah, using Ubuntu. Okay. Not sure. Well, if you can rephrase that, that would be nice. So you have different images that you can use. Some of them are free trial, so stick with the free trial ones for a start. So you can literally spin up any of the machines. For Mac OS, I think you need something we call dedicated server to spin this up. When you try to go for Mac OS, I think there is one more step, like into filling some a little bit of application or so. Yeah, but yeah, literally, you can just go with you know, uh, the light Linux, Windows. You can go for Windows servers and so forth. I think we also have Windows 11 or so. Yeah, but you can literally search for the operating system, the image you're looking for based on what you're looking for. So some people go to market to buy Windows, some people go to market to buy Linux, some go to market to buy Mac OS. So preference. But for this session, since Linux actually lead on the vote, so we go for Linux. So I just stick with the Amazon Linux right here because it's also under free trial, and I can actually choose the architecture I want to use. If it is, I think this S82 is usually Intel, and the AMR is usually AMD. You can literally choose the architecture as well. So for the instance, it gives you option. I think they have changed their interfaces a little bit, but I think they give you a default instance type that comes with that operating system or the OS, like the CPUs and the RAM. So this actually gives you, yeah, you can actually choose more. You can change it, but at default, it will give you the T3 Micro, which is a free trial, and this comes with two virtual CPUs, 1 GB of RAM, and it give you, yeah, you can literally see, you can literally click on additional costs to see all the. Okay, no, that's not what I'm looking for. I think you can click on the drop down right here to see other instance types. Yeah, so you can actually see other instance type right here. So we have like T small, P large. These are like, when you're trying to buy a laptop, when you try to buy a machine, the more CPUs and GPUs they have, the more money you pay for. So if you're going for like 2 core CPUs, 4, 10, that's more money as well. And the same applies to the RAM as well. Yeah, so the larger you go, the larger you pay. So, example, if you're going for like say 36 CPUs, oh, so you get the concept. The concept is the more devices you need, the more hardware you need, the more you pay. Okay, so we just stick to the free trial. T3 is a free trial, but we can actually go lower if we want to. I think there's a C. Yeah, I don't think this one is free. Yeah, you can just stick to the ones that are free trial. So you have the T3 Micro and the T3 Small. These are all free trial. So you can literally stick to that. Now, by free trial, it does not mean they are not going to charge you if you leave it on for a longer time. If you do, you get charged as well. So always make sure when after spinning the machine, you're no longer using it, turn it off. And of course, they'll give you 200 credits if you sign up, so you can, it will be the prices will be taken from the credits as you go. So let's stick to that. So we have what we call the key pair. Think about this like your locker, like your key. So you need a key to open the lock. So think about like the machine, like when you put in your password to access the machine. So this is literally a key. You can if you have you can just click on create a new key pair right here. So we just do that. You can give it this a name. I'll call this Cloudman as well. They have key pair types. We have the RSA and the EZ25519. I just go with the encrypted private and public key pair. This is Linux, so we can stick with the .pem. But if you're using that's if you want to access the local machine, if you want to access your virtual machine from your terminal, so you can actually use the OpenSSH. But then if you're using a software, we have a software called Putty. There's a software called Putty. It's also a client that allows you to connect to virtual machines. So if I think is available on Windows, yeah, this is it. Literally, you can just download it. Also, for Windows, you can use that. It allows you to connect and access your virtual machine. But we stick to RSA because I want us to make use of the terminal since we're using Linux. So Cloudman, I create on key pair. So automatically this will, okay, it's not showing up, but it will download, like it will download on your local machine automatically. I'll just go ahead and save it. Okay, I'm not showing that part of the screen, but yeah, I'll just go ahead and save it on my local machine. So once you create it, you'll see a download pop up. You can save it on your local machine wherever you want to save it. Okay, so I have saved it somewhere on my machine. So do I need any other thing? I can actually allow for the networking settings. How do I close this? Yes. For the networking settings, I think automatically it will attach itself to the default VPC. VPC is a cloud private. What's the full meaning again? Give me 1 second. But think about VPC as a warehouse. Think about it like an estate. Yeah, it's a virtual private cloud. Think about it like an estate. An estate, inside the estates, you can literally have. Should I use an estate? Yeah, I think an estate makes sense. You have an estate. Inside the estate, you have different houses. Yeah, think about it. Think about it from that perspective. So VPC is just like an estate that can have different houses in it. So you can create a VPC that has a specific, resources. So like an estate, inside the estate, you have houses inside those estates. So only the people living in that estate have access to the estate. So they can access the estate and use the resources in the estate. So the same concept goes with VPC. It's just like an estate, and you can actually host services or resources within that estate. It automatically when you create an account, a VPC is created. So when you're creating a virtual machine, it will attach itself to the VPC and the security group attached to the VPC as well. I think I have a comment here. I have used Google Cloud Platform. I use this in Google Cloud. So yeah, cool. Yeah, so you can actually do the same thing in all any cloud platform, Microsoft Azure, AWS, and Google Cloud Platform as well. So we have these options: allow SSH traffic from. So this is literally networking perspective, right? The VPC, the security group. This is how we tell our computer how we want to communicate with it. If I'm spinning up this machine and I'm the only one to access it, I can actually say I want to access this from my IP. So I can literally, there's an option for that, my IP. This will show you your IP. You can also do a custom. We can provide the CD block that can access it. So the whole essence of this is, let's say you're spinning up this machine for to be used internally in your organization, and your organization have their own machine, right? From the VP, from the IP address, like everybody when you come to the office, everybody's going to get to the same IP. So if you want only people in that IP to be able to access this machine, yeah, think about it from that perspective. So you can actually configure that. So this is coming to networking perspective. So how you want to access the machine. But for now, I'll just leave it at anywhere. So I can actually access it from anywhere. Like I can access it from any laptop. I can access it from anywhere, in as much as I have the key to access it. Uh, yeah. So it also gives you the default storage, which is free trial eligible, which is like 8 GB. You just leave that at default. And that's pretty much it. Like it's actually that simple. You just choose an operating system, create a key pair. You can create a on-net security group, or you can attach the existing one, and you can choose the storage you want, and you can just click on launch instance. But you can also do more advanced details if you want to do other like advanced settings and so forth. But we just skip that. And I just click on launch instance. So this will take a time. It will take some time, some minutes to spin up and launch. Okay, so it says successfully initiated launch instance. So you can just go ahead and click on that instance. Again, it's still spinning up. It just initiated the instance, but it's spinning up. So behind the scene, what is happening? What is happening is somewhere in North Virginia, USA, because that's the region I'm in. So right here, you can see the region I'm in currently. So every resources I'm creating will be living on that region. So every resource I create will live on this region. So somewhere in North Virginia in the United States, there is a data center owned by AWS that is allocating a virtual machine. There's allocating a piece of hardware for me. They are provisioning a piece of hardware for me. They are partitioning and they're partitioning a part of the hardware, putting the operating system in it, the storage and so forth, so I can use it. So I'm renting just a piece of the hardware somewhere in North Virginia, United States. All right, so let's see. Instance that is running. I think that was fast, but let me see. You just go to instances. Yeah, it's still initializing. So if you look at the status check, it says initializing. So it will take some few times, maybe 2 or 3 minutes to initialize, because it's a physical hardware. It's like when you're partitioning your laptop, the amount of time it takes to partition a piece of hardware. So it's still the same process. So it's going to take few minutes to partition. I can always refresh to check that. So while we're waiting for that, I just want to know if anyone is following along on the comment section, if anyone spinning up a local machine, spinning up a virtual machine on their end, let me know. Of course, if you have questions, also ask on the comment section. Okay, so while we're waiting for that, we can take a 2 minutes break, a 2 minutes water break. And when we're back, the machine should be spinned up. We can now look at how we can actually access the machine that we have spinned up. If you have questions, go ahead and ask me on the comment section. In the next 2 minutes, I think our machine should be spinned up by then, and we'll continue. So I'll be back in a second. Okay, right back. So I'm going to refresh again on the console. Let me see if, yeah, our machine have spin up. You can see the check status, a 0/3 checks passed. So what this means is our machine is running, so we can literally click on it, and we can look at how we can connect to it. So I'll go ahead and share my entire screen now. Okay, so I think we have access to my entire screen. And how can we connect to our local machine now? We can click on the connect option right here. It gives us different options how we can connect. But our the goal here is to connect using the SSH client. If you're on Linux, if you're on Windows, if you're on Windows, I think you should have. Yeah, let me see. If you're Windows, I think the SSH client is also installed on it. But if it's not, you can install that. You can search for how to install that. Yeah, I think you can actually install the menus for Windows. Yeah, that should work. If you are on Linux already, I just dropped this on the comment section. If you are on Linux or Mac, I think you can install the SSH client via the terminal. That's if it's not already pre-installed. I think it's always pre-installed with the terminal. Yeah, I think it's always pre-installed with the terminal. It's always pre-installed via the terminal. But I think you can also, yeah, I think it's always pre-installed via the terminal. Yeah, it's always pre-installed via the terminal, if I'm correct. I'm on Windows, but I'm going to use the Ubuntu WSL. There's a Windows kernel for the Windows Ubuntu kernel. But I think the terminal is now, the Windows terminal is now rich. Last time I checked, let me see. Terminal, yeah. I think it has if you're on Windows 10, I think the Windows terminal now comes with, I think you have PowerShell in it, you have the Ubuntu. I think this comes if you install the Ubuntu WSL, basically, which is what I love to use. You can also ask the command prompt. How do I check for, let me check that. How do I check for SSH? Okay, I think you can type in SSH-V to check for the version. Yeah, I already have it installed. I think it's the same command if you're on Ubuntu as well. Like if you're on Linux, not literally Ubuntu, but if you're on Linux, it's the same command. You can just type SSH-V. Yeah, that is taking so much time. So I use the small v here. It should be a uppercase V. So it gives me the open SSH for Windows. So if you're on Windows, you can just use PowerShell. I think that should also work for the command prompt as well. Yeah, that also works. So you can literally use that here. If you're on Linux too, you can also do that. I think there's some commands everywhere. Yes, it is. Yeah, that should be uppercase V. That should just give me the version. So you can use that to check on your end if you have SSH installed. I think it comes pre-installed these days with PowerShell, command prompt, Linux terminals. So it should be pre-installed already. Okay, so I'm just gonna stick with using the Ubuntu kernel. It's still the same thing. So I just want to connect to my local machine. So what I'm going to do right here, I have already downloaded my pin. That's the key. We created the key pair we created, and it's somewhere on a folder called dev. Let me see if I do ls hyphen a. I think I will see it. Yeah, right here, cloudman.pin. Yeah, so this is the file I need. So it is already here. So I'm going to make use of that. Connect. So you need to make sure that on the directory you are is also where you have the PEM file that you download there. That's a key PEM file you download there. So you have to be in the same directory. Okay, so let's see. Open your SSH client, locate your private key file. So make sure you're in the same directory. So run this command to. So basically, what this command does, it makes the PIM available. Like it makes the PIM file. That's the PIM file we created earlier. It gives it permission. It's basically makes it publicly viewable. So it gives it permission to execute and read. So that's what this cmode 400, then the name of the PIN file literally does. So just go ahead and run that. Yeah, if you just run, nothing will come out on the screen. Then you can just connect. You can just connect to the instance using the IP address. This is the public DNS, literally. This is like a full example of how to connect. So SSH-I, which is like initialize. So you can just copy the example from the screen right here on your AWS console and just run it on your terminal. So this will is not going to ask you for any password or so because you already have the key. So the PIM key is literally our password in this case that we can use to connect to our local machine. So let's see, this could take like few seconds. Yeah, it shouldn't take that long, but let's see. That is taking much longer time than expected. So I'll just go ahead and cancel that. And I'll just run it again. That is literally taking forever. I don't know why it's taking that longer, that much of a time. Okay, let me see if it is terminal. I just open the Ubuntu app directly. Okay, not quite pretty sure why it's taking forever to spin up. Yeah, that shouldn't take that much of a time. So let me take a look at our terminal. Let's see if we're missing anything. Our instance, let's be sure is running. Yeah, I think it could be my network per se. Yeah, so it says time out for two connection time out. Yeah, I think it has something to do with my internet connection. Yeah, I'm just gonna switch to a different network right now. Let me see if that solves the problem. Okay, I think I was gone for like a few seconds, but I'm back. So I switched to a new network and I'm going to try it again. Let's see if that solves the problem now. Yeah, I don't know why it's taking forever. It shouldn't. It should spin up real quickly. But it gave us a timeout error. So it was literally. Okay, let's check our security. Let me head back to here. I'll go to networking just to make sure we have everything in place to connect. So I'll check for the inbound. Yeah, the port 200. Yeah, the inbound port 2022 is actually allowing traffic from anywhere. So this, yeah, this shouldn't be an issue. So we have our port 22 allowed to connect from anywhere. And we also have our outbound. So the most important one was the inbound, which is available and can communicate from anywhere. So we shouldn't have an issue. So this points to a local machine issue like network. So let's give it another try. Let's see what happens. But why on that? Let me see. Any other way I can connect to? I think they have the session manager. No, EC2 used to have EC2 Instant Connect. I mean, this will give us a simulation of what we are trying to do. If we're trying, I'm which connects to the machine and give you access to the cloud. Yeah, I'm not pretty sure why we are unable to connect here because it's timing out. So it's literally a network issue, something to do with my network provider. Yeah, I think it's an issue with my local network right here. Not pretty sure why it's not connecting. I think I have a pretty much fast internet, so it's not literally the internet per se. But let me give that a try again. Connect, and I will. Just before I use the instant EC2. I just run the cmod command again, and then I'll try to connect to the instance from here. Anyone willing to try to connect to this from the end, like from your terminal? I don't know. I need someone to try to connect it from the end. I can send over the pin and you try to connect and let me know. Anyone on the comment section? I just want to make sure we have this working from another person's end as well. So while on that, I'll just go ahead and try to connect with the EC2 Instant Connect. Okay, so I think this is maybe from AWS end, because the instant connect should always work. It doesn't actually need like a network security and so forth. It always works. So not pretty sure what is happening. Error establishing SSH connection to your instance. Try again later. Hmm. I'm not sure. I'm not sure what's going on. But let me make sure. Let me just check the status heads. I could check that directly from here. Yeah, it's timing out. I think it's something to do with either my local network, or it's something to do with AWS right now. So not pretty sure which of them. They don't have any current issues, so not an issue with AWS then, because they don't have any reported issue. So everything here looks fine. Okay, so I'm going to do this. I'm going to spin up a Windows machine just to be sure if it's an issue for my end, or something else. So I'll make this fast. I actually noticed some lag on my network. So let me switch back to the network I was. Okay, so I'll just call this Windows Cloud. I'll choose Windows right here. I'll just go with the Windows Server 2025 base. For the key pair, I'll go ahead and create a new key pair. But this time I'm going to use .ppk for putty. Yeah, I'll just save that. This should go to my download. Yeah, I'll leave everything as default. And I just launch the instance. I'll go ahead and check the instance. While I'm on it, I think I'll install putty. I'm not sure I have it, but let me check. I do. To download putty sites. Yeah, I think the reason this is timing internet from my end, that is why it's not connecting. But let me confirm that because everything is a little bit slow from my end. I just want to confirm, has anyone on the screen been able to spin up a machine and connect from their end? Let me know. I just go ahead and download the MSI window installer for putty. It should show up. Not sure why it's not showing up. That's strange. Let's try it again. It's not giving me option to download. Why? Okay, I think it shows up now. I just go ahead and download that. Yeah, it's just still not connecting. And the issue here is timing out, which I'm pretty sure is the network issue. But let's try using the Windows operating system and see. Okay, so putting installed, I have to install it after downloading. I just go ahead and drop the link on the comment section as well. So you're trying to download Putty, you can just use that link. Click on finish to exit, view with me file. No, just go ahead and open it. This is it, recently added. So this is the app. This is what it looks like. Now this looks like the configuration. Hostname, the port, SSH. Let's see. 1 second. So I just go back to my instance. Okay, I think it's running. I just go ahead and click on it and connect. Just to make sure we have everything in place. Go to security. Port range 3395. Okay, let's see. So click on the RDP client and just download the remote desktop. I think this gives you a username and a password, so we don't necessarily need this. Just close this. You just download the file. You can save it. Yeah, keep. I'll go ahead and open that. Yeah, go ahead and connect. So to try to connect to the machine, we just spin up. Cannot connect to a computer for one of the reasons. Remote desktop to server is not enabled. I'll just try that again. Okay. I think this should be coming from Putin now. Let's do some configuration then. Let's see. Let's troubleshoot and try to fix this just to be sure. For inbound, this is actually correct. So, well, let me make sure. Yeah, but this, yeah, it's a type of RDP. The TP, this protocol TCP, and the port is 3398. So everything here is actually correct. Not an issue with our security group. So, what could the problem be? And I'm connecting from anywhere. Now, I don't want to use my IP, so I just want to stick to anywhere IP4. Yeah, just leave it anywhere IP4. Save changes. Yeah, did not actually make any changes. So this is actually correct. So what could the problem be? Yeah, I still having timeout here. Yeah, pretty much a network issue. So not pretty sure. I think the reason none of this is connecting today is my network issue. But if anybody tried it on your end, should successfully be connecting. If you're having issues, let me know as well. Our configurations look correct. We have ports open and we allowed it to connect from anywhere. So pretty much a network issue, which is why we are unable to connect from my end. Yeah, but yeah, I'll go ahead and troubleshoot this later on my end, and I will actually post a follow-up video on the Discord so you all can follow along. And yeah, Don't forget to give us feedback. I'll just go ahead and drop the feedback link on the comment section. And also the next stream coming up will be on JavaScript. So if you are interested in learning about JavaScript and what JavaScript is all about and how to get started, you should be looking forward for the next stream. Please don't miss that. Okay, so I just dropped the feedback link on the comment section. So let us know what we can improve. Let us know what we can do better. And I'm going to go ahead and keep troubleshooting this on my end, fix the problem, and I'll just record like a follow-up video for this, and I'll post it on the Discord channel so you all can follow along as well. Thank you. And if you have questions, follow-up questions, you can reach out to me on Discord. Happy to answer any of that. Okay. See you on the next stream. Bye.